It is another episode of Star Wars The Force Awakens, Forces in Motion. In this video, we are going to be covering Section 3, Motion and Forces. The important terms are force, net force, friction, and air resistance. An important unit that you're going to want to write down for force is that it is measured in newtons. And for short, we write that with a capital N. On our first slide, we're going to go over the definitions of force and net force, and then I will go through these three examples about what net force means and how to calculate it. Then we'll define friction, and then list the different types of friction, and then finally we'll go through air resistance, and air resistance is a type of fluid friction. As usual, go ahead and write the question at the very top of the page. What does the force of friction between two objects in contact depend on? Then go ahead and title this page as Section 3, and the title is Motion and Forces. Our first term is force, a push or a pull. So anytime you have two objects either pushing or pulling on each other, that's called a force. A force is also the thing that causes an object to accelerate. So it's what causes a change in velocity to occur. I'm going to just put a delta for change and then a v for velocity. So it causes a change in velocity to occur. Then net force, that is the total force that is acting on an object at any given time. So here's some examples to show you what it means by the total force acting on an object. So in our first example here, let's say I've got two people pushing on one object in the middle, and they're pushing with forces of equal size but in opposite directions. That's called balanced forces, which means that the net force is equal to 0. So the net force is just the total amount of forces added together. What I have to do here, because they're acting in opposite directions, is I have to think about one direction as being considered the positive direction and the other being considered the negative direction. Normally, when I try to decide which direction is positive and negative, I just use the way a regular number line or a graph would be, so that going to the right is positive and going to the left is negative. So that would make the first number here, if this is the 2 newtons going to the right, that would make this positive. And then the other one, which is the 2 newtons going back to the left, that would make that negative. So then they would cancel out, so you would wind up with plus 2 newtons plus negative 2 newtons being equal to 0 newtons. So that's the idea behind this whole balanced forces and adding all of the forces up. The total force is just all the forces added together. Now my next section, the next picture here, is showing unbalanced forces. So let's say instead of just having 2 newtons on either side, I've got 2 people now here. 2 newtons and 2 newtons, and then 2 newtons going this way. Well, in this situation, on this side, I'm going to have 4 newtons going to the right and only 2 newtons going back to the left. So my net force is going to be 2 newtons to the right. So this one cancels this one, but this one is not canceled. So my net force, or my total force, is 2 newtons to the right. Now let's try this one. Let's say unbalanced forces where we just have 2 different numbers. So here I've got 2 forces that are going back towards the left. And since they're going in the same direction, we're going to just add them together. So that's 2 plus 4 is 6. And I could, since I was using this convention over here where going to the left is negative, I could call that negative 6. or I can draw an arrow to represent that it's going that direction, or I might even just write 6 newtons left. That's fine too. But it is actually important to identify both the size, which is the 6 newtons, and the direction. We want to always have direction with a force. Direction is important. Okay. So again, there's lots of different ways to represent direction. Sometimes we use it with a plus or a minus. Sometimes we use an arrow. Sometimes we actually use a word to describe it. Sometimes you might even just say in the direction of the applied force or in the direction of the motion. If you're really, really being vague on directions and there's not a lot of information in the problem about directions. Okay, here's the friction situation. Friction is a type of force. So friction is just in the overarching category of forces. So it's like the big umbrella term is force, and one of the things that is covered under that umbrella is friction. And there's other types of forces as well. But what friction is, it's a force that opposes the sliding. So it's always going to act if you've got two objects, and let's say you've got this object and it's sitting on a table, and you try to push it along. And so this is the force of my push. Friction is always going to be the force that's acting in the opposite direction. So it always opposes the sliding motion between the two touching surfaces. And that's caused by things called microwelds. And so here's a picture of some microwelds that you can see super zoomed in. So this says times 16,000. So this is really zoomed in. And sorry about the dog. So there's lots of types of forces. There's any time you are pushing on something, actually applying a pressure to something to push it along, that's a type of force. If you grab onto a rope and you give it a tug, that's a pull. That's a type of force. The force between two objects, gravity, that's a type of force. There's magnetic force that pushes things apart, and there's friction. And there's actually lots of types of friction. So there's going to be 4 types of friction that we're going to go over. The first one is static. And static, I like to think of the beginning of the word static like the beginning of the word stationary. Static means that it's not moving. So if you have static electricity, that's electricity that builds up on the surface of maybe your shirt or your pants or something, or a doorknob, and it doesn't go anywhere until you touch it, and then it goes into your body and it makes you feel that shock. But we call it static electricity because it's not actually moving. Now, this isn't talking about static electricity. This is talking about static friction. Static friction is when the friction between two objects is so big that they won't slide at all. They won't even move. They're just stuck there. So an example that I like to use is if you're trying to move your fridge and you pull or you push on it really hard, but it's so heavy that the friction between the fridge and the floor won't let it budge at all, so it won't move. So anytime something is not moving, that would be a good example of static friction. Another great one, of course, is something that you guys have probably all had to do in gym class, a wall sit. Yeah. So if things are going well and you've got static friction pushing up and keeping you from sliding down, then you're going to have a very nice wall sit. But if you don't have enough static friction, if that's not big enough, then you're going to have this kind of friction, kinetic friction. And that means that this force is smaller than the force of gravity, and you're gonna go wah wah wah. Brr. Ah, I fell on the floor. So that's friction where two surfaces slide past one another. So another example would be sledding down a hill. Whee! La 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 la, going down a hill. The last one, the second to last one is rolling friction. So if you've got tires and they roll, then that is what we call rolling friction. And so this is actually a little bit weaker than kinetic friction. So kinetic friction means like two flat surfaces that are sliding past each other. But rolling friction is actually just this like rolling situation where you have very, very little surface touching and it's always rotating around. So like a skateboard, rolling friction. And then fluid friction. Fluid friction is when an object moves through a fluid. Now remember, that can be a gas or it can be a liquid. So that is both gas and liquid. So in a gas, that could be in air, skydiving, and swimming in water. But anytime you have an object that is moving through a fluid, gas or liquid, that's called fluid friction. So one type of fluid friction is air resistance. Fluid frictional force that opposes the motion of objects through air depends on speed and shape of the object. Air resistance is also known as drag. Now, it depends on speed. The faster that an object is going, the more air resistance it's going to experience. If you've ever been in a car and you stick your hand out the window, you know how you can that's a horrible hand. Oh God. You know how the air's coming along and it'll like push your hand back and you can like make your hand kind of go wee up and down and up and down. That's kind of what I'm talking about. That works better when you're going faster. When you're slower, you're not getting very much air blowing against your hand, so it doesn't work as well. So more air resistance with greater speed. And it also depends on shape. And so that's to do with like how spread out you are. So if you're a skydiver, if you are straight up and down, you're going to go a lot faster, or rather probably head first, so you're a little bit more aerodynamic, right? You'll go a lot faster than if you decide to lie flat out like this because your body is more spread out. And then even more air resistance when you open your chute, because this is all, of course, designed to catch a lot of air to increase the amount of air resistance. So it's really important to remember that this is a force. So air resistance is, in fact, a force. It is the upward push of the air on whatever object is falling. To summarize, a force is a push or a pull. A net force is the total force, all of the different forces added together, acting on an object. And it's also important to notice that opposite directions will cancel out. So if I have something going to the right and something going to the left, they can cancel each other out. Though if this is only 4 and this is 7, well then my force is going to be 3 back this way. So it's only going to cancel out part of this because this one's smaller. Then frictional force is the force that opposes the motion of objects in contact based on the roughness of the surface. And the 4 types were static, which was the stationary one, kinetic, which is sliding, rolling, which is self-explanatory, and fluid, which is through anything that is a gas or a liquid.